meteor if the owners of the site will let you do that. And you can pick up bits of that meteor. So, something like this happens on the Earth every few thousand years. This one is about 50,000 years old. I forget the exact age, but it's quite well preserved. Most of the time they happen in the ocean, and then even if they actually reach the bottom of the water, they get covered over by sediment fairly quickly. There's a bunch of other impact events of craters of different sizes scattered around the Earth. Many of you may have seen this still from a video. If not, you can go onto YouTube. Those of you who are already watching on YouTube, you can look things up while you're watching me. You will see all sorts of videos of a place called Chelyabinsk in Russia. It's a city of 1 million people, roughly. Just over 5 years ago, this happened, just around local sunrise. So the asteroid in this case was about 15 to 20 meters across, much smaller than even the meteor crater in Arizona impactor. This one came at a very shallow angle, and so rather than actually coming to the ground intact, it was stopped pretty high up in the sky. Now the asteroid has fallen through the Earth's gravitational field at this point. Relative to the Earth's orbit around the Sun. All that kinetic energy has to go somewhere. It gets converted, in this case, to heat and light and sound. The fireball very briefly outshone the Sun. There were a couple of cases of meteor sunburn, which is not UV burns, it's just the sunlight, not sunlight, the meteor fireball light getting focused a little bit. People were standing in awkward locations and actually get significant skin damage from that. More common problem. What do you all do when you see a bright flash of light in the sky? I'm hearing various responses here, and people in Chelyabinsk had many different reactions. A lot of people ducked. Other people went to the window. The shockwave travels at the speed of sound. 30 seconds to a couple of minutes later, depending on where in the town they were, shockwave hits the window. There were a lot of injuries from broken glass. There are also a lot of injuries afterwards, people stepping on the broken glass. 1,600 people were injured. Nobody died. It was a pretty near thing. Something like Chelyabinsk impactor happens somewhere in the world once every 30 years. Most of the time over the middle of the ocean. That's the problem. What we'd like to know about the next one happens over a city. What happens? It's operating with this. There's a large number of survey programs that have been funded by particularly NASA for the last more than 20 years now, and also doing funding from other countries. You see here the 3 most prolific at the moment: the Catalina Sky Survey in Arizona, the Pan-STARRS project in Hawaii. The Wide Field Infrared Space Explorer was initially an astrophysics satellite. It's been repurposed for its extended mission solely to find and track near-Earth asteroids and characteristics. They still have a blind spot because we can't really observe directly near the sun. There's a proposal out of the Agricultural Laboratory in Pasadena led by Amy Mainzer that would call NeoCam that would use technology-derived WISE to look right near the sun in the infrared from space, which you can't do from the ground. And that way you can find asteroids that are coming straight towards us from that direction. But the general goal here is to find as many Earth asteroids as possible to predict their orbits out as far as we can. Currently, we're discovering about 2,000 Earth asteroids a year. I say we, I'm not involved in survey programs myself. Many dozens of people involved. And I work in credit for a lot of people. I do mostly characterization of asteroids that won't fill this far. This project has gotten called Space Guard after a World War II sequel, but it has done its job. Initially, the goal was to find all the Earth asteroids all over the planetary land, because a bit like that, no matter where it hits in the world, we're going to have a very serious problem. Fortunately, we are now tracking all of the hallmarks. We know that we found almost all of them, because gravity discovered them went off very steeply in the 1990s as they can't see